Hi, welcome back to the breadboard. Today is Sunday the 29th of May, and what that means is it is the first day of Texas Instruments IoT week. And to share that with you guys, I've decided to create a week-long project where every single day I will progress an IoT device from inception right through to a working device that participates in the internet, the cloud as they call it. Will have data sent out to the internet and made available on a smartphone, and also it will be collecting temperature and light levels. In this particular case, every single component where possible will be using a Texas Instruments chip or board or processor in order to achieve this project. Let's have a quick look at what is involved in the overall view of this, and then we're going to start selecting components. Now, I've already gone through the process of selecting the components, but I do want to walk you through some of the boards that are available from Texas Instruments. They're called Launchpads, and all of these are effectively evaluation modules, development kits that you can buy very inexpensive and figure out your application and everything else. And then if you want to take it to a production level, then of course you can just buy the chips and design your own boards, etc., etc. So let's go look at the design that I've come up with that I want to achieve by the end of the week, so we can see where we're going. You may choose to pick different boards, different parts, and that's up to you. I may be able to provide some help, but I'll be focusing on getting this particular project through the week and done for the end of it. Lots of videoing, lots of editing, so you'll have to bear with me. Anyway, let's go look at what we're going to try and build, and then we'll start looking at components that we're going to use for that. Okay, so I just put a little diagram together in Visio to basically try and show you what we're going to do. And if I start from left to right, we have some kind of temperature sensor. And I looked on Texas Instruments site and looked at what parts I had to hand, and the one I chose that we're going to use for our project is a TMP275. This is a precision temperature sensor that can communicate with any microcontroller using the I2C bus, and it has an accuracy of about 1/2 degree. That's its initial absolute accuracy, and it is a 12-bit or 6, sorry, I'll have to check. I'll provide the specs anyway. I think it's between 12 and 16 bits of resolution. We're going to have a light sensor, which is going to be in the form of a fairly standard light-dependent resistor. You can pick these up for way under $1 each if they're just the sensor itself. And if you get them in some kind of industrial package, I happen to have a couple knocking around the lab here, then you might pay a lot more. You may pay as much as $30 or more, depending on who you get them from. We're going to need to pick a launch pad. So the one that's being shown here is the EXP 430 F5529. It's about a $12 launch pad. It doesn't have any Wi-Fi on it, so you'd have to add a Wi-Fi board in order to do what we want to do, because I want to have this Wi-Fi attached, not hardwired. The other board I'm showing down here is an option. So there's this one, and this one is a CC3200 Launchpad. It's a little more expensive than the 430, but it has built-in Wi-Fi and a bunch of other features as well. It's about $30 to buy. Now, of course, if you look at this one and you add a Wi-Fi module, say 20 bucks, then you're actually, this is $32 and this is only $30. So you're a little bit ahead buying the integrated module. And there are some positives about this, which I'll mention as we go through some of the other launch pads. We're going to need some kind of display. So what I'm going to do is the one I've picked to use, which is Sharp 96 display, is the Sharp 96 means it's got 96 pixels across and 96 pixels down. It's only black and white, or more silver and white would be the right term, I think. It's a highly reflective, very high contrast display, and it takes almost zero power to run this thing. It is extremely low power. So if you wanted to do a battery operated system, it would be an ideal choice. Another thing that I'm adding to the hardware of all of this is a Texas Instruments fuel tank booster pack. Now I know these are obsolete, but I'm using this one because all of the chips that are used on the booster pack are available, and it's using a lithium-ion battery pack to power the circuit. So we're just going to use this to show that this whole thing can run completely autonomously from external power supply, and you could even wire this up with a solar panel if you wanted to. So whatever loop we're going to do, we're going to be collecting temperature, we're going to be collecting light, we're going to be processing it on a launch pad with a local display so you can see what's happening, and then we're going to send it out via Wi-Fi through my home network out to the cloud up to an MQTT server. Now what this MQTT is, it's basically a messaging publish subscribe server. I'll provide the links to mqtt.org so you can have a look for yourself. I'm then going to have a Node-RED instance, which is a product that IBM created, and it's available for free for almost every single platform you can imagine. That will subscribe to the data that's being sent to the MQTT server, and it will process it and render a web page for me that I can look on any smart device, and whether that be a tablet, a smartphone, or whatever else. It's basically an HTML5 page. It's really easy to do. The focus of this whole week project is not really so much about Node-RED. I've got plenty of videos on my channel already that shows you how to use Node-RED and do some graphing and all sorts of other things. So whilst I'm going to show you the results there to complete the picture, I'm not actually going to go into a lot of detail about how you use Node-RED in this week's Texas Instruments IoT week. So that is basically what we're going to try and achieve. We're going to have a local Wi-Fi connected node that's going to collect temperature and light, and it is going to send it up into the cloud where the data can be subscribed to by a, I mean, it doesn't have to be Node-RED, but in this case I'm using Node-RED, but any MQTT subscriber can subscribe to that data and then render it onto some kind of device. And in my case, I'm going to use a web page, that because that's so generic to almost everything that that people have these days, that it makes sense to be able to do that. And that's it. So let's have a now look at some of the launch pads that are available, and I'll give a little bit of a brief description as to why some of these were eliminated from my selection criteria. Okay, I've spread out before you a range of Texas Instruments launch pads that I happen to have at the moment, and some of them are, well, one of them in particular is very, very new. Some of them are quite old, and then there's sort of a few things in between, and their capabilities range quite substantially. So starting on this side here, what I have here is an MSP 430G, and it has a MSP 430G 5529 processor on it. I don't know. And what that one has is it has a processor on it. It's just a small one. It's got a speed up to about 16 megs. It only has 16K of flash and a half K of RAM. It does have a couple of timers, and it does support the protocols we need to talk to our hardware. It has I2C, SPI, and an serial TTL port on it, and it does support a 10-bit analog to digital converter as well. The problem with this, though, is because of the software, we want to be able to run a network connection. We want to be able to process an I2C stack, and we want to be able to drive an LCD display, which means you have to have a font and things like that. These ones don't have enough memory in them to be able to do what I want for the flash. Now, if I was maybe using this under Code Composer Studio and not Energia, I might be able to squeeze it in, but I still don't think ultimately it would be able to work properly for what we want. So the next board I have here is the EXP430 FR5969, and this one has a supercapacitor on it as well. The chips here, you've got all of these boards support the standard booster pack extenders. This is the standard 2 rows of 10 pins, and then you've got, as we'll see in a moment, the XL version where it's 2 rows of 20 pins for the expansion, and then you have even bigger boards that have 2 complete booster pack ones, and we'll get to those in a moment. Anyway, this one is a board that's used for ultra low power applications, and from that perspective, you would think that it would be a great candidate, because this thing can actually run for quite a time just running off of this little super cap here, rather than having any other batteries or anything else connected. Now this one, the 430FR, what did I say that was? 5969. It also will run up to 16 meg. It's got 16K of flash and 2K of RAM on it. It has a 12-bit analog to digital converter, and also still supports the timers, I2C, SPI, UART, etc. Now, I think the problem I had with this one was that it wasn't able to handle all of the different booster packs that I was going to have to stack on top of it. Because it only has 2 rows of 10, i.e. the standard booster pack pins, using the Wi-Fi module requires using an XL kind of connector. So that really was one of the things that put it out of play here. So going up around the line here, the next one I have is the EXP430FR4133. And this one actually has a built-on LCD display, which would be really cool. But it still only has the standard 2 rows of 10 expansion connectors. But that wouldn't necessarily preclude it. Now, this particular one, what it has on board, I have that actually upside down. Actually, that's the right way up for it. The 4133 has 16K flash, 2K RAM, so I don't think we'd be able to squeeze everything into that. And I did try with these with the close to final code, and I was getting errors on some of them where it said it wouldn't fit, so that precluded that one. So the next card in the range is one of the newer ones from Texas Instruments, and it uses an MSP432 processor, and this one is able to run up to 48 megahertz, and it has 200. So it runs this new one, the 432, runs at 48 megahertz, and it's got 256K of flash on it on the board that's built in, and it has 64K of RAM. So technically this one is capable of doing everything we want, but the problem is that a lot of the libraries are not yet set up to work properly with this. So I was getting some issues with trying to get everything running properly on here. Outside of that, I mean, it's because it's a newer board and I'm using Energia, not Code Composer Studio. I think if I was using Code Composer Studio and more familiar with it, I would probably get a lot further ahead with getting everything to run on here, and that's something for another day. What I want to do with this project is I want to make sure that it's familiar to the biggest audience. So that's why I'm sticking with Energia, because if you're an Arduino user, the environment will be almost identical to what you're used to. The next one running around the line here is a TIVA C series Launchpad. This one is using the TMC4 123G CPU on here, and this is an 80 megahertz Cortex-4 processor with 256K of RAM, of flash, 2K of EEPROM, and 32K of RAM. So it's got I2C, SPI, UART, it's got a CAN bus, it's got 12-bit ADCs in it, plus. It's a very capable board, and it's an ARM Cortex M4. Now, again, the reason I'm not using this one is because I had some issues trying to get the I2C bus to work and all the I/O working properly on it. So I did have a look at it, and there may be, with some tweaking of the libraries, be a possibility to get it working, but I wasn't able to get that one up and running in time for this project. It is a nice board though, and I've done some projects in the past with it, and it's very, very fast. So we will be doing some more work with the TIVA C series later on. Okay, next one round the line is a connected Launchpad. This one is a little unique with the Launchpads. This one is the TMC4 and this one has 120 megahertz CPU on it. It's got a meg of flash, 64K of EEPROM, 256K of RAM. It's got the I2C, SPI, UART, CAN bus, 12-bit ADCs, and it also has built-in Ethernet capability as well, which makes it a very, very capable board for hooking up to the internet. because you can just hardwire it straight into here. Now, the nice thing about this one as well is it is very, very fast. So if you are wanting to do some high-speed reading and writing of data, it would be more than capable of doing it. Now, the problem and the reason I haven't used this one again, I think, is because also being an ARM Cortex, one of the ARM Cortex boards, I had some issues with getting the Energia drivers to work with it. The last one on the back stack here is a very new board, well, newish to me anyway. It's a C2000 Launchpad XL. This is using a TMS320F28069M processor on this board. And the unique thing about this is it's designed for the InstaSpin. It's got hardware in here that makes this board ideal, or the CPU more importantly, ideal for performing motor control, three-phase, generating three-phase motor control, etc. from DC supplies. It's got the high-speed PWM. This one is also very good for projects where you may drive a buck converter or multi-level power supply intelligently. And I will be doing projects later on. I'm gathering together all the parts to actually show you how you can use this for a buck converter, for a power supply, maybe a lab power supply, things like that, and also how you can use it to drive DC and stepper motors and various other things with various types of feedback. So look forward to that later on, but for now, because this one is so new, Energia doesn't even have it listed in the list of boards that it has. So unfortunately, I'd like to have used that one, but it's out too. Now, the one at the front here that I have is the one that's actually hooked up and running right this moment. If I bring this, so there we go. This is a stack right now of boards. If I tip it sideways, you can see it's got the MSP430. It's got the processor. I'm going to show you just with static pictures. So this one here is the CC3200 Launchpad, and what is unique about this one is the processor has built in, as part of its hardware, a full Wi-Fi stack capability. So from the fact that we want to have Wi-Fi with our project, it's an ideal candidate. The CC3200 Launch XL, which is what this one is based on, I know I've got the other bits on top of it, is an 80 megahertz ARM Cortex M4 based processor. It's got a mega flash 64K EEPROM, 256K of RAM, plus the 12-bit ADCs, the I2Cs, SPI, and UARTs, etc. So from a hardware perspective, it is ideal for this project. Some of the other things that are built into this is a sensor set that comes on the board as well. It actually has a no contact temperature sensor, and it has a 3-axis accelerometer that you can use, and they're both connected through I2C bus. I'm not going to use them in this project because I want to be able to have a light sensor that will, via a wire, be able to get plugged in and set up wherever you want it to be, even if it was outside. And I also want to be able to use a temperature sensor. Where is it? It's here somewhere. So I'm hanging on the end of this little piece of wire right now, which is the TMP275. I've got it plugged in on the I2C bus as well. I know the ones are built on the board, but if you were setting a project up, you would want sometimes to have this in a case and have the other parts externally. So I'm not going to assume that we're going to have these two sensors available, and it means that you're going to be able to easily replicate this even if you don't have a CC3200 or parts of the program anyway. And this board here is the one that I'm actually going with for the project. Now, the last board we're going to look at is this one here, and this is a EXP430 F5529. So the EXP430 F5529 LP is another good candidate to use for this project because it does have plenty of RAM, plenty of flash space. It's fast enough because, as I said, it's running at 25 megahertz. And it's got a decent analog to digital converter for reading in values at a pretty good resolution. But we do have two options. which is the, as I said, the 5529 and the CC3200. The reason I'm going to go through the project with the CC3200 is because the Wi-Fi capability is built right into the processor, so you don't have to add another board to it. It's one less stacked header on the system. You know it's going to work right off the bat, and you can get these boards for $30. So the price of this is less than the price of this one with a Wi-Fi card. Now, there are other options for Wi-Fi and Bluetooth and sub-gigahertz radios and everything else, but my desire for this project is we're going to connect it to the Internet of Things. I want to get the data straight out on the Internet to an MQTT server, so I want to have it Wi-Fi connected. I also want to be able to run it with battery, so these have got a battery booster pack. That's the last board that's on the end here. That's the booster pack. See, it's got the lithium-ion battery on here, and it's got buck and boost and charge control circuitry on the other side. It is quite capable. There's a few mods that I've done, and I'll provide a link actually to a blog that I did a couple of years ago on it, where I modified it to improve its power preservation capabilities, just changing the mode of operation. So the selection for the week is going to be the CC3200 with the sharp display, because I have lots of them and they're ultra low power, and it works with this particular combination. We're going to use the battery booster pack, the fuel tank as TI calls it, and element 14. We're going to use the TMP275 Texas Instruments precision temperature sensor, and we're going to use a standard light dependent resistor. Now the one I have here happens to be in a industrialized case, but it is just a regular one. If I can find one that is just on its own, that we can just plug into a breadboard, then I'll pull that out and show you with that instead of this, just so that you're comfortable that all will work. Now I have this running right now, and I can show you right here that this is the temperature here, and this is the light levels that have been getting trended over the last little while it's been running. Here's some gauges with the same values on them, and then here's the spot values that have been coming in from the MQTT server. Every time anything comes in, it automatically gets reflected onto this screen. So this is what we're going to end up with by the end of the week. Now don't worry if you don't have an Android phone. This will work on a tablet, a PC, an Apple phone. Pretty much anything that has a fairly recent browser will be able to render this as well. It is a home automation system that we're trying to build here, and going back to this diagram, this is what we're going to build. Okay, so the direction we're going to go is this sensor, this battery pack, this Launchpad, which is the CC3200. We're going to go via Wi-Fi out in the cloud to an MQTT server. I'm going to have Node-RED running on a Texas Instruments Citara processor, pulling in the data by subscribing to the MQTT, rendering a web page to make it available to a smartphone. We're going to get this done in 7 videos. This one is video 1, and we're going to get it done by next Saturday. So I hope you stick with us, and I hope you enjoy this, and I will see you tomorrow.